Hello, my name is Martin Velez, and in this video I want to give you a quick demonstration of the CompAssist system. So the CompAssist system is first a web application that suggests patches. It takes your code and compiles it, and if the code does not compile, it searches for related fix examples. It groups those fix examples into patches, and it suggests patches to fix your code. So let's take a look at an example of that. So I'm going to type a simple program, int main parentheses int x is equal to 0 semicolon return 0 semicolon. I'm going to click compile, and now you see a new interface. In the top left you see the code editor. On the bottom left you see the compiler output. You also see the compilation command. On the right you see an empty list of possible patches. And now let's introduce a simple error to the simple code. I'm going to delete the semicolon and line 2. I'm going to click compile, and now I see an error message in the compilation output. So I see that the error message is expected semicolon at the end of declaration in line 2, which is exactly what I did. But I also see a list of possible patches. I see 26 possible patches. The first patch is insert semicolon, the second patch is delete right parentheses, and so on. Inside this patch, what you'll see is our fix examples, and these are distinct pieces of code that represent a buggy, an uncompilable piece of code with a patch and a patch that makes it compilable. And you'll see a lot of fix examples all grouped by patch. On the right you'll see this label auto experiment success, and what this means is that since there are only 26 possible patches, we can actually apply the patches to the code and see what fixes it. In this case this is checked, which means that if we insert the semicolon at some place in the code, it will fix. The interface doesn't tell you the location right now, but we're working on improving that. Compare that to the second patch, which suggests delete the right parentheses. So there's only one, and if you delete that, it won't compile, as you can see in the code. So the check mark isn't there. Let's take a look at a more complex example. So this is a Stack Overflow post by a user that wanted help with their compiler error. So this is the code that they posted, and I've gone ahead and transcribed it. So here is the code. I am going to put it in the code editor to replace the simple code, and I'm going to click compile. And again, you'll see that there's an error message. This time the error message is cannot cast cat to its private base class animal, and it says that it points to lines 33 and line 12. And then on the right side you see a list of possible patches. In this case there are only 3 possible patches, and again you'll see fix examples. The first patch is insert public. Again, the interface doesn't tell you where. We're working on improving that, but if you look at the example and you look at line 12 as pointed out by Klang, you'll see that a possible fix would be to add public here, right? And the reason for that is because in C++ inheritance is by default private, so you need to add this modifier. Okay, and you'll see that the check mark is here, which suggests that yes, if you do this, it will make your code compile. So let's click compile, and as you can see, that does in fact fix the compiler error. Now if your code is correct, that's a separate issue. Okay, so moving on, the CompAssist system is also a database of compiler errors, error messages, and fix examples. So right now it supports Clang++ -3.9, and there's about 1,800 kinds of errors, and there are about 39,000 different error messages, or concrete error messages, and there are over 116,000 fix examples. So let's go ahead and take a look at that part of CompAssist. So this is the page for Clang++ 3.9, and a compiler, if you're familiar with compilers, you're probably familiar that there are different kinds of errors. So for Clang++, we counted about 1,800 different C++ errors. So here's one example. Cannot initialize a value with an R value of uncompatible type. So if we click on that, it's going to take us to its individual page. We'll see that its name in the source code is init conversion failed. We'll see the template, and if you scroll to the bottom, you're going to see that an error has many possible instantiations. In this case, the actual concrete messages that the user sees. So the user doesn't see the error or the kind of error or the template. The user sees the concrete error messages, and we group them up. We group them up thanks to the source code. So thanks to the Clang source code. So in this case, you'll see that this is a concrete error message. This is a distinct one, and if you click on one of them, it's going to take you to its individual page. And for this concrete error message, you're going to see that we were able to get 102 different fix examples. And in this case, this one suggests delete the return, delete the return, delete the return, but this one says delete throw. This one says delete void. So the patches are, the fix examples are different for this particular one. So again, a compiler can have many different kinds of errors, as you can see here, and those errors can have many different kinds of, many concrete diagnostic messages, and those diagnostic messages can have concrete fix examples. Okay, now that's one way of viewing it. Another way is you can search for concrete error messages using a search bar. So if I type in expected, you're going to see that it takes me to, it shows me a list of 762 diagnostic messages with that word, and I can find one. I can find one that's relevant to me, and I can look at fix examples. So this one, for example, has 400 fix examples, and that may give you an idea of how to fix my error. The other interface, of course, groups them up in a much nicer way. I can also type in cast, which is a word that we saw in one of the previous examples, and you'll see 1,200 concrete diagnostic messages that have the word cast. Okay, and here's a good example of a concrete diagnostic message which we only have one fix examples. In some cases, we have a lot of fix examples, but in some cases, they're not easy to trigger for some reason, and we don't have that many fix examples, but we do have, in this case, we do have at least one. So in the future, what we want to do is we want to improve coverage. Right now, for the 1,800, which in fact should be about 1,600, we have about 50% coverage. They're about half. There's a little bit less than half of the errors which we don't have fixed examples for, so in the future we want to improve that coverage. And we also want to support more compilers. Okay, so that should cover this demonstration. I hope you enjoyed it. Thank you very much.